Okay, so we are doing dimensional analysis day 2 notes. If you go to our notes page, they look very similar to day 1. In fact, so similar that we are not going to repeat it. I'm just going to page back a second here. We'll go over some of those vocabulary terms. So the ratio is a comparison of two quantities. Okay, you don't have to write these in, it's fine, they're right here. A rate is when two quantities have different units, so like words per minute. The unit rate is when we get that to 1, so 50 words per minute. What you learned new with day 1 was about dimensional analysis. How do we convert from one measure or a rate to an equivalent measure or a rate? So we started with some basic problems. The only other thing that I want to talk about here is I'm going to do just a recap of each of those questions with you. So how many inches are in 6 feet? So if you start with 6 feet, we can multiply this by our conversion factor or our conversion ratio. So in 1 foot, there are 12 inches. And I know many of you can figure this out without setting this up, but this is going to help us when we encounter more difficult problems. So 6 times 12 would give us 72 inches. The feet cancel, and that's your answer. The next type of problem that you guys had in your worksheet were a comparison problem. Now, if you have something in yards and something in feet, in order to make a comparison, you have to get them in the same measure. And so we can either convert 16 yards to feet or 50 feet to yards. It does not matter. So I'm just going to take 16 yards and I'm going to convert it to feet. So I know that in 1 yard there are 3 feet. So that's going to be my multiplier. So 16 times 3 would give me 48 feet. So who's bigger? 16 yards, which equals 48 feet, or 50 feet? Well, we know our 50 feet is going to be bigger. You don't have to do it twice, as long as you get them in the same measurement. So the new stuff, the uses of dimensional analysis go far beyond conversion between simple measures. It can be also used to convert and compare rates with different measures. Examples include miles per hour to miles per minute, dollars per pound to cents per ounce. We could think of other ones. So like you could do, I'm just trying to think, maybe you want to do words per minute to words per hour. Maybe you want to know gallons. What was I going to do? Maybe we want to do gallons per mile to gallons per kilometer. Using dimensional analysis to convert rates is slightly more difficult, but it's also more useful. So the how to do. So our first example, we are going to start with $144 per pound equals how many dollars per ounce? Okay, they assume that you know how many cents are in a dollar, if that's necessary. So set up what you are given. So this is kind of look like what we were doing before. You take your given, how do we get from point A to point B, and then how do we get our answer? So we're just going to fill in some blanks here. So we need to get from, we want dollars per pound to dollars per ounces. So what we are changing is our pounds and our ounces. So in 1 pound, there are 16 ounces. 144 times 1 is 144. 1 times 16 is 16. And then your last step is you take 144 and divide it by 16. So we get $9 an ounce. It's very expensive, whatever you're buying. So this is much like we were doing before. Multiply across the top, multiply across the bottom. Make sure your pounds canceled. We didn't want the dollars to cancel because we wanted with dollars per cents. So the answer is that $144 per pound equals $9 per ounce. You can fill in those numbers down here if you'd like again, but it doesn't matter. They're already kind of there for us. Okay. So that was when you just canceled one. Now some problems, you are going to go from, like in this one it says inches to feet and minutes to hours. So we need to change both of our factors. Okay, so if you have to change more than one, that means that we're going to have two conversion factors in here. The first one is changing minutes to hours, and the second one is changing inches to feet. It does not matter which one you do first. In fact, the way that I learned this, I changed my top one first and then my bottom one second. But it doesn't matter because we're multiplying, and the order of multiplication doesn't matter. So I'm just going to fill in what they have here. So there are 60 minutes in 1 hour. This is my conversion factor to go from minutes to hours. Minutes is on top, so they cancel. And then I'm going to kind of ignore this one, and I'm going to go from inches to feet. So there are 12 inches in 1 foot. And inches has to go on the bottom because inches was on the top. So then when I do my multiplication, I would take, 4 times 60 times 1. And that's going to give me 240. 1 times 12 is 12. And then 24 divided by 12 is 20. So very similar to how you guys did it in your warm-up. If you want to fill this in down here, you also can. There's 60 minutes in 1 hour. There's 1 foot equals 12 inches. 4 times 60 times 1, you multiply the numerators, you get 240. Multiply the denominators, you get 12. And our final answer is 20. So 4 inches per minute equals 20 feet per hour. Now the reason why we do some of these conversions is because in some things, feet per hour probably has no relevance, but maybe miles per hour, we all know kind of speed in that sense. So sometimes you convert a given one to one that we know how to relate to. That's the biggest reason why we use dimensional analysis. Okay, so here is our practice. It says Jimmy can eat 3 jelly beans per second. So let's take what we're given. 3 jelly beans per 1 second. Yep. How many dozen jelly beans can he eat in 1 minute? Okay, so the first thing is that we're going from single jelly beans to dozen jelly beans. So what's the relationship between something and a dozen? 12. So we know that there are 12 jelly beans, and that equals 1 dozen jelly beans. So this is kind of a strange one. And then our next conversion factor is seconds, and we want to get to minutes. So what's our relationship between seconds and minutes? 60, yep. So 60 seconds is going to go on the top, and 1 minute goes on the bottom. So jelly beans and jelly beans cancels, seconds and seconds cancels. We don't need to write this twice. We can just do our multiplications. 3 times 1 times 60 would give us 180. 1 times 12 times 1 is 12. $180 divided by 12, and then this was dozen jelly beans, and then this was per minute on the bottom. That's what was left over. So what was when you solve this, 15. You get 15 dozen jelly beans per 1 minute. So Jimmy can eat a lot of jelly beans. Okay, so Jimmy can eat blank dozen jelly beans in 1 minute. 15. Okay, so I am going to do one from each side of your worksheet with you. I think what I will start with, and I will do a 2 conversion one with you, because those are a little bit harder. But notice how they have 2 spots, so you kind of know if you need 1 or 2. So let's do the first one, maybe. Or I don't know, let's do H. So we need to go from dollars to cents and pounds to ounces. So you can kind of look at how they want your end question there. So I prefer to start with the top. So how many cents in a dollar? James? 100. So I would put $1 on the bottom, and I would put 100 cents on the top. I put the dollar on the bottom because I want my dollars to cancel. And then we just got done doing pounds and ounces. So I should have 1 pound on the top and 16 ounces on the bottom. The reason is because pounds and pounds are going to cancel. So now we can do our multiplying. 8 times 100 times 1. If I multiply across the top, 8 times 100 is 800. And then 1 times 1 times 16, you multiply across the bottom, and you get 16. And you get 50. So we get 50 cents an ounce. Okay. Now let's go to the other side. I'll do one with you from the other side. Is there any questions on this one? Okay, so I gave an example for you here, but sometimes it's nice to see an example live as well. So, pick a letter. F? Okay. So we are going 8 inches of writing per 1 gram of pencil lead, and we have to go compare 20 feet of writing to 1 ounce of pencil lead. Okay, now it does not matter which one you convert. So my habit is to start with the one on the left and work right. So I'm going to take 8 inches. I need to go from inches to feet. And then 1 gram, and I need to go grams to ounces. So this is just my little note to myself of what I'm going to do. I know I'm going to need 2 conversion factors. So if I start with the one on the top, you guys should know how many inches in a foot, right? 12. So I'm going to put 12 inches on the bottom because I want them to cancel, and 1 foot on the top. So inches and inches cancels, so we're good. Now we're going to do one more. Now, grams and ounces, if there's any that you don't know, look at the top of your paper. How many grams in an ounce? 28.35, that's right. So grams needs to go in the top. 28.35. It needs to go in the top because grams is in the bottom over here. So that's per 1 ounce. So I know that grams and grams are going to cancel. So now when I do my multiplying, 8 times 1 times 28.35, I get 226.8. And then on the bottom, 1 times 12 times 1 is simply 12. You need to divide, and I get 18.9. Now what is that? It's feet per ounce. Okay, so you have to remember that you just took the 8 per 1 gram, and you got 18.9 feet per ounce. So this is 18.9 feet per 1 ounce. So who's greater, 20 feet per ounce or 18.9 feet per ounce? 20. So you only had to do one of the problems. You could have done the other one, but you know which one you're going to get it into based on which one you're comparing it to. Okay? And that should be enough to get you started.